All right. Welcome, everyone, to this Radio Shop chat that's organized by SpectrumX, the NSF Spectrum Innovation Center. My name is Nick Lanneman. I'm a professor of electrical engineering at the University of Notre Dame, and I'm serving as center director for SpectrumX. I'll be handing things off to my colleague, Monisha Ghosh, shortly to introduce today's speaker. But before I do so, let me just share 3 reminders with you. So first, SpectrumX is the world's largest academic hub through which all stakeholders can collaborate and innovate to make the best use of the precious radio spectrum to benefit society. Second, the purpose of this Radio Shop chat series is to bring the community together to educate, debate, and inspire next steps in our collaborative research, workforce development, and policy outreach. Third, the Radio Shop chats follow the Chatham House rule, which means that participants are free to use the information received, but neither the identity nor the affiliation of the speakers, nor that of any other participant may be revealed. So thank you once again for participating. We hope you enjoyed today's chat. Please spread the word and get involved. And now I'll hand it off to Monisha to introduce today's speaker and topic.
Thank you, Nick. We're very excited to have Dr. Steve Leach talk to us. He will be presenting a newly proposed sharing model, the hybrid sharing model for the upper 6 gigahertz band in particular, but hopefully some of these ideas may be applicable to some of the other bands. Which regulates the UK communications industries. During the last 12 years, he has been working to enable new wireless services in the UK while making sure existing incumbent services continue to operate. This is becoming increasingly important as we look into the future of spectrum. Prior to joining Ofcom, Steve held a number of different roles in wireless consulting firm, where he was responsible for radio surveys, indoor cellular and Wi-Fi system design, and technical consultancy projects as CTO. He is also an engineering champion in his local schools and supports career development initiatives, which is wonderful, and a trustee of a couple of charities providing education and support to disadvantaged women and children in Africa. Steve, welcome to the Radio Shop chat. I think we will take questions at the end, but please type questions into the chat as you think about them, and we'll get to as many as we can at the end of the talk. Over to you, Steve.
Thank you very much. I'm hoping that you can now see my screen. Marvelous. So I now need to just slightly switch screens so I can see. So I probably can't see all of you now because I'm presenting. So do, if there's questions that are kind of pertinent to what we're talking about, then Monisha, feel free to interrupt, but probably better if we save the majority of substantive ones to the end. That's probably a good thing. So first of all, we're just really going to talk about how our hybrid sharing model could enable the benefits of both mobile and Wi-Fi use in the upper 6 gig. But before I do, I just thought I would do a bit of introduction to Ofcom. So we are the regulator, the UK regulator, both for competition, for the communication industries, and we look at sort of TV, radio, various fixed telecom services, postal services, which most people don't seem to kind of realize that we do, but of course the wireless devices and services that we use every day. And I guess the equivalent is probably we're a little bit of a mix of both the sort of things the FCC does out in the US and also a little bit of the NTIA function as well. We don't have those separated in quite the same way as you do there. So that's what we do. But we have a duty, particularly around optimal use of the radio spectrum. So this is about making sure people and businesses have connectivity where they need it, when they need it, how they need it, to serve both their personal desires for using kind of internet and internet on the go, but also their kind of business operations. And things are wider than I think quite a lot of people expect, possibly not this community, as you're probably quite experienced in spectrum, but we can't also aeronautical services, military services. We'll work very closely with our military colleagues on some of that, and healthcare and program making special events to do with video cameras, wireless microphones, those kind of big events, those kind of things. So it really covers a whole range of what we do, and we think about all of those things in what we're doing. But back in 2021, we set up a strategy for Spectrum for really the rest of this decade, with a real focus on ensuring innovation, growth of existing users and new users. In particular, we were looking at kind of continued improvements, really, so a bit more of the same in terms of wireless communications by everybody. And that's what I said earlier about wherever you want them, whenever you want them, they need to just work for you. People are becoming a little bit, less concerned about the type of service that's delivering it. They just want to be able to be kind of connected. But we also recognize that businesses, public sector, other organizations, these kind of types of enterprises have different requirements. They have very specialist requirements in some cases, and they still need the right wireless communication system or the right spectrum options for them. So this is very much not all about mobile or all about Wi-Fi. It's all about all of those people, all of those services. But that comes with an increased flexibility in spectrum to support that kind of innovation, and that needs assurances for everybody, really. So continued use of existing services, use of new services. People need to feel that they're going to get a kind of quality that they can rely on, and so forth. But we're also very focused on sustained improvements in the efficiency of spectrum. That's really important to us.
That's really question that we may have to answer during a subsequent meeting.
Somebody needs to mute. I think it may be gone. Can somebody on the Spectrum X side mute Yvonne?
Those activities or meetings that I'm looking to schedule, follow meetings I'm looking to schedule, we could definitely have that follow conversation.
Yvonne, I think you need to mute your mic.
Okay, Angelica.
Yeah, hi, Angelica Molin. I'm also with the Register team, and I'm on the business side, working very closely with AT&T and others on ORA.
Tiffany, do you think we can mute everybody from our end?
Yes, I'm doing that, working on that right now.
And I was at the MPIA 5G Challenge last week and met some other colleagues.
Sorry about that, Steve. I think you should be good to go.
No worries. That's great. I'll continue. So our focus on kind of all of these four streams that you see on the left of the slide now, that sort of brought with it a bit of an increased focus on three things. One is supporting wireless innovation. We recognize there's real value to the economy, value to businesses and consumers as well in that kind of wireless innovation. It's really important that licenses are kind of fit for what we need, and that means probably more local licensing and national services. So we recognise there's a place for both. Traditionally, we've been very much focused on the kind of national services, particularly for kind of wide area mobile coverage. Perhaps that's changing a little bit as we move forward. And the third point, which I've kind of put slightly bolder at the bottom, is about promoting spectrum sharing. We recognise that the days of a siloed bit of spectrum that you can use for mobile or for broadcasting or for satellite, those days are coming under pressure, I think, that approach, just because there's more demand for wireless services, there's more things that want to go in there, and actually packing people closer in geography and closer in spectrum terms is probably quite an important thing to do, basically. So that kind of spectrum sharing and that element of good neighbours is something that kind of underpins what we do. So this just kind of sets a bit of the context that I kind of wanted to do at the beginning as to kind of why we're looking at, what some people might think of as quite innovative potentially in terms of looking at hybrid sharing of both mobile and Wi-Fi in the upper 6 band. But there kind of is a good reason for that. And if I skip to the next slide. Oh, there we go. I'm probably going to skip too many now because I've clicked it several times. So if it goes forward, I'll have to go back. But the landscape is changing. It's a growing data consumption. But as I said before, people are generally a little bit agnostic about how that's delivered to them. So we see people using mobile phones for their internet access. We see them using Wi-Fi connected to kind of fixed residential services. And so specifically in the UK, we've seen sustained growth over the last decade of both mobile broadband and Wi-Fi networks. And you can see on this chart that the sort of bluer colour is the public mobile networks, and the green colour is the fixed residential traffic, which we sort of take as a proxy for Wi-Fi being served there. These continue to grow. We saw fixed grow, a little bit faster than it was doing during sort of pandemic times of 2019, 2020. And then we've seen that growth rate fall off a little bit, but it's still growing in recent years. And we sort of see an average of 30 to 40% growth probably in mobile traffic over the last decade, depending on exactly how you do the averages of those numbers. And video sharing, social media platforms, streaming, cloud-based services, they're all drivers for this. What we tend to find in growth, as I guess you're well aware, is that you get new applications or new services or new things that take off, and that creates a little bit of a kind of ramp up in demand for a few years, and then that kind of stabilizes, and people are doing that, and then you get the next thing. So things are necessarily a little bit lumpy. So we tend to want to take slightly longer term averages rather than the really short term stuff. And mobile is increasingly making use of Wi-Fi offload, whether that's just offloading data through your home Wi-Fi network, through corporate mobile networks, through public Wi-Fi networks, I should say, or whether that's about Wi-Fi calling specifically in those areas. But there is much more, it's much more seamless than kind of where it was before. So upper six is quite key, and depending on who you talk to, very key for enabling this data growth, and is the only solution that might be there, according to some parties. But there's a bit of competing demand for this. So if we talk to the mobile industry, they will tell us that increased macro site capacity in key areas is really important. That putting up a 6 on the same mast has got 3.5 gigahertz for 5G in the UK. It is great. It's got a similar footprint of coverage. Others might tell us that actually it's about a small cell layer with additional capacity, delivering a slightly better performance than perhaps millimeter wave might offer you in those small cells. But equally, the Wi-Fi community will tell us that improved Wi-Fi user experience is really important. We need more data. We're getting a lot more fibre in the UK now, to either to the home itself or to the kind of curb outside, and therefore much higher data rates in the home. And therefore, the distribution of those high data rates arriving at the home is all about distributing it around the house using Wi-Fi or other license exempt technologies, but predominantly Wi-Fi. And if you're in those dense residential areas, then you can get quite a lot of congestion on the current 2.4 and 5 gig bands, although we've made lower 6 gig band available for Wi-Fi as well, and that's just starting to roll out now. Enterprises look for really ubiquitous coverage over their building. So that's about using different channels, channel reuse, and therefore, if you've only got access to 5 gigahertz and the lower 6, you can only do a certain number of channel reuse. If you've got access to the upper 6, then you can have either more channels of reuse or the same channels of reuse, but we double the bandwidth in each channel. So again, that kind of improves performance. And then there's also some debate about innovation, so those really wide 320 meg channels that will give you really low latency for the kind of augmented reality, virtual reality type services. They're also something. So this makes life a little bit difficult for us. And you'll see in this next slide that, I mean, I'm sure I'm telling you stuff you already know, but predominantly in the Americas, you see that actually most of the 6 gig band, the lower and the upper 6 gig band, has actually been made available for Wi-Fi. In Europe, you see the lower 6 has been made available for Wi-Fi, and there's a bit of discussion about what happens in the upper 6 band, and kind of in Africa, well, it's really about the lower 6 band, and there's been not much discussed really in terms of the upper yet. So the Americas have kind of moved on Wi-Fi. We see a few other places where they're looking at mobile in some of the upper 6 band, and that's been kind of decided. And I think it's fair to say Europe's on the fence still, and we'll see this play out at the World Radio Conference, particularly in kind of region 1, while we're considering that kind of upper six band. So this leaves us, I think, as a regulator with a bit of a challenge, because on the surface of it, if you listen to the mobile community, then it's the thing they absolutely need and it's really important. And they say, well, there's no demand for Wi-Fi. And if you listen to the Wi-Fi community, they say that's absolutely the thing that they need and there's no demand for mobile. So that leaves us, I think, as a regulator in quite a difficult position, because we have to choose who do we believe most, who do we think has got the best evidence, or we pick a winner. And I would argue that the demand really from both sides is probably still emerging. Actually, I think most people would probably recognise that the demand is still emerging, and it might be some years before we get a really clear view as to which one is going. So then, do we decide later? Do we not decide at all? Do we just delay our decision? But actually, we tend to find that driving the equipment ecosystem is relatively important. That decisions are made, and that helps manufacturers and chipset manufacturers develop their equipment and kind of know the standards and know the harmonization that they're going to. So we've got this fantastic idea, which we think is about actually there's a great opportunity for sharing. And we consult on this in July, and the rest of this talk is really about trying to take you through some of that journey and some of the things that we're thinking about. And I think it's fair to say up front, we don't have all the answers. We know we don't have all the answers. What we're trying to do is to drive a discussion, basically, and drive that development of how this might work. So really in July, we proposed kind of there's probably sort of 3 areas really that we were looking at. One is, encouraging the development of technology-based solutions. So we are, I'll come on to a bit more to this, but we are looking at managed database solutions. We're looking at kind of dynamic sensing. We're keen to kind of leverage the stuff that's out there and not reinvent the wheel. We think that's cheaper and probably faster to do those things. We think actually sharing mechanisms are needed, and a number of players will tell us Wi-Fi and mobile can't share. And actually, I completely agree. Mobile as it is today and Wi-Fi as it is today doesn't share that well, and I'll come on and talk a little bit about why we think that's the case. And there's existing users of the band. There's a bunch of incumbents that I'll come on and talk about as well that are in the band and need to be facilitated. But just because mobile as it is and Wi-Fi as it is today doesn't share, doesn't necessarily mean that the mobile service and the Wi-Fi service couldn't share at some point in the future. But we also recognise that economies of scale is quite important for equipment manufacturers. It's quite important for consumers in the UK. Actually, the UK market's not massive, so having that international harmonisation, whether that's European or global, is really important in terms of driving that. So we think in terms of sharing, we can exploit the kind of different deployment topologies to enable hybrid sharing. So there's an example here where broadly in the UK, Wi-Fi access points tend to be deployed indoors. 99 point something percent of Wi-Fi access points are indoors. They carry that very localized indoor traffic, whether that's in an enterprise, whether that's in a residential premises, usually tethered to some kind of fixed broadband service. Mobile base stations are predominantly outdoors, and they provide that wider area coverage. And so there's a kind of natural indoor-outdoor split already of where base stations are located, although that's not necessarily the same as where coverage is located. Actually, the upper 6 band isn't very good in our view in terms of providing indoor coverage from outdoors. Particularly, we see in the UK now a move for more thermally efficient buildings. That means they're great at managing their kind of heat and energy consumption, and really terrible, as I'm sure you all know, about managing, RF performance through those walls and through those metallized windows and through all of those things. So there is an element of kind of natural shielding here. And you see in the middle graphs, we've got this is actually our building in London, and that's the 4 mobile operators that we've got. And you see that, you've got pretty good green, good coverage outside. And actually, when you come inside, particularly in the top left, it's really quite poor coverage indoors from outdoors. There's either some really no coverage or some intermittent coverage. There are other bits of the building with other operators where maybe in the bottom right, for example, you see much more green indoors. So there is a service that's being offered outdoors in. But in all cases, the back of the building, far away from the outside bit, or far away from where the base stations are delivering 3.4, 3.5 gigahertz 5G. Actually, at the back of the building, you've got pretty poor 5G coverage actually from there. So we think there's an opportunity to say, well, actually, if Wi-Fi can exploit that area where there isn't outdoor coverage, then maybe even in the same geographical area, you can get Wi-Fi and mobile, both providing some level of service. And if you can offload some of your outdoor mobile traffic onto upper 6, then that frees up some of the lower frequency bands that might be able to be used for leveraging predominantly indoor traffic, for example. But we also, the last bullet point here, we find the bulk of data traffic in mobile networks is still quite concentrated. And actually, that map on the right-hand side, which is from 2022, you can see the sort of darker the red, the more concentrated it is. So that's some of our big towns and cities that you see in the UK, where that's predominantly really dense. That map hasn't changed in the last 5 or 6 years, if not more. The actual amount of data that each pixel's carrying has probably changed quite a lot, but proportionally, where you've got high demand is where you've always had high demand, and it's the towns and the cities. And some of the more rural areas, there is scope to use some of the existing bands that aren't necessarily fully used. So moving on, I said earlier, we don't think mobile and Wi-Fi actually shares very well as it stands today. And this is some of the evidence that we gathered and some of the evidence that we presented in our consultation. But essentially, we're saying unmanaged co-frequency sharing results in quite an unpredictable interference environment for both networks. And that needs to be managed, basically. We could try reducing the transmit power of outdoor mobile macro sites, but that's not really going to fix the problem. And there will be a number of areas of interference. So these 2 graphs on the left, they're just some access points in 6 gigahertz that we tested. We put them in an environment where there was mobile in the band. So this is simulated mobile. So we were actually using the lower 6 access points, and we put mobile simulated mobile base stations co-channel. You can see that the performance degrades as the unwanted signal increases. When the unwanted signal is about the same level, that would be 0 dB on the bottom line, and you see it all completely fails. That dotted purple line on the left-hand one, that's when that access point switched to a different channel that wasn't being interfered with, and you can see it kind of sorts its life out and gets back to 100% of its throughput. You see a similar story when you've got 50% loading on the mobile network. You still get pretty big degradation of Wi-Fi, and even when your unwanted mobile signal is 20 dBs below your Wi-Fi signal, which you could well be in an indoor environment, you still got pretty down in the kind of 20% of your throughput on Wi-Fi. It's not a good picture. We also see that the Wi-Fi has the same potential to degrade 5G downloads. So if you've got an access point indoors that hasn't backed off because it hasn't heard an outdoor, base station, but then it's transmitting, that transmission will interfere with a kind of indoor or outdoor mobile user equipment and degrade that performance too. So we agree these things need to be managed. These things need some kind of sharing mechanism, some kind of coexistence. And is not something that we can necessarily achieve on our, with the current technology as it stands today. But we really want to start with the kind of existing mechanisms. We think exploring improvements to those is really efficient. So we're talking about sensing. Are there improvements in listen before talk? Are there ways of hearing mobile in a way that is different to the way it's detected today? Can we use databases, whether that's the SAS, CBRS kind of database, or the AFC database, both of which you've got in the US, or probably a combination of both actually. And I'll talk a little bit in a minute about a few scenarios where we think it might be one or the other or both. We think that's the greatest chance of success actually if you leverage what we've got today. We expect trade-offs. The complexity of the mechanisms, the extent to which different systems can use the spectrum. You could make it a really complicated mechanism and you could squeeze more sharing in, but actually maybe you need a slightly simpler mechanism and a bit less sharing, because that's just more efficient and more cost effective in terms of hardware development, and those kind of things. But these technologies we sort of think underpin the kind of dynamic spectrum sharing. And will give some gains in efficiency. We believe that actually if you can leverage most of your mobile demand and you can serve most of your Wi-Fi demand, the sum of that is better than just choosing a winner, whether that's mobile or Wi-Fi, and also means we don't have to risk picking the wrong one in that scenario. So the point is about making use in times and places where different users are transmitting, and therefore where one user is not transmitting, maybe the other type of user can transmit. So this is one of the examples. I've got a few of these slides that I'll go through. So this is looking at a kind of AFC type database. This is saying actually we're going to prioritize mobile. In order to not interfere with mobile, we're going to keep Wi-Fi away from those prioritized mobile areas. That looks very much like the kind of AFC type database that is in existence today, that is implemented for standard power. Slight extension of that is that we're talking about potentially Wi-Fi being indoors, not outdoors. So we might need to think about, how you geolocate those indoor access points, for example. But the example here might be the centre of London is a priority area, but the suburbs are not. In which case Wi-Fi is what you would enable there. The next one is looking actually about times of use. So we think actually databases could help prioritize here. So this is about looking at technologies by time as well as location. So the first one was about choosing them by location. This is saying in a football stadium, for example, we might say on match days, lots of people using Wi-Fi in the stadium. There's lots of services being provided to the fans, to the audience, whatever the event is there. And actually using upper six for Wi-Fi in the football stadium is the right thing to do on match days. But at least 6 days of the week. And probably more than that when you consider a month, because there's not necessarily a match every weekend. Actually, maybe mobile in the area is kind of fine because there's not much going on at the football stadium. There may be a bit of corporate stuff going on, but there's not that massive thousands and tens of thousands of people going on. So you could say actually we're going to prioritize Wi-Fi and therefore keep mobile away and prioritize mobile other times. And that would look a bit more like the kind of SAS scheme or CBRS type scheme that you've got in the CBRS band at the moment in the US. We also think maybe there's even more kind of localized sharing, so not just in areas. And this is where we start looking at sensing, for example. So those graphs or those plots I showed earlier about outdoor coverage and indoor coverage in the back of the building where there was pretty poor outdoor coverage from mobile, maybe Wi-Fi could start to exploit that. So even when you've got a high priority area in London, for example, where we're going to enable mobile as the priority, if you had better sensing on the Wi-Fi and it could detect that mobile was there, then Wi-Fi would, I guess the equivalent here is that if I deployed lower and upper 6 gig in the Ofcom building in London, the access points at the back of the building I want on upper 6, and the access points at the front of the building by the windows I want on lower 6. And that way the lower 6 wouldn't interfere with the upper 6 mobile outdoors, and the upper 6 mobile outdoors wouldn't interfere with the Wi-Fi at the back of the building indoors. That's the kind of vision that we have. And that's looking at how you enhance the sensing to make sure that you don't just completely kill Wi-Fi. It allows it to switch channel. You maybe need some different protocols around channel switching in there so that you do navigate away and don't just stop working, because that's not really ideal. And then maybe you get a little bit of both actually. So for example, in that example of the football stadium, we might well allow non-match days mobile to have the highest priority and be used in that environment. But actually, if you were deep indoors in the stadium or you've got some corporate event going on in your hospitality boxes, Some of those may well be able to use Wi-Fi indoors if they've got good shielding, or they're on the far side of the stadium, for example. You might well be able to use Wi-Fi indoors without interfering with the mobile outdoors. And so this is not necessarily removing use from one use or the other. It's about saying opportunistically you can both use it, and you can kind of find a way of doing that. And then sort of looking at this, the Upper 6 is also used for a bunch of existing services in the UK. So we've got fixed links, and you can see from the dots on that right-hand map of the UK, they're different colours, but they correspond to different sectors. They're kind of where fixed links are. So you see them kind of speckled across the whole UK doing different things. Those red ones that look like they're in the sea genuinely are in the sea, because they're serving oil rigs, for example, out there. So it's not something dodgy with our plotting. They're serving oil rigs. So there's fixed links, and we know that high power mobile outdoors and fixed links don't necessarily make happy bedfellows. So that needs to be kind of managed. If you've got some kind of database, then that might work with some of this. We've got some satellite earth stations, both permanent and transportable earth stations, that we need to manage. We've also got wireless video, part of the program making special events for those wireless cameras that are used for broadcasting. They make use of this band, for those particular events in a particular location. Then there's incumbents that also would need, either they can't access the spectrum at all, or you need to manage them somehow so that they know that they've got clean spectrum in a particular environment because mobile's not there or Wi-Fi is not there, for example. We've got some radio astronomy sites, and we've got some short range devices as well in here. So all of these are also relevant in the kind of context of sharing. And maybe you wouldn't build complicated databases to support these particular services, but maybe where you've got these services and you've got other sharing mechanisms that we're thinking about, then they also might have an ability to do this. So we've kind of indicated that if you did high power mobile and you had lots of fixed links in London, like you can sort of see some of those brown dots on the right hand graph there. Some of those might need to be cleared, so that mobile and fixed links don't interfere. But actually, if there was some better way of doing that you could allow more fixed links to remain in the band, and that would also be an efficient use of spectrum, because you've got incumbent and Wi-Fi and mobile all kind of sharing spectrum in a hopefully very harmonious way. So this sort of brings me to our next steps, really, and the sort of further work that we're looking at. So key for us is actually, what are the parameters that we would need to protect licensed mobile? How would we do that through Wi-Fi? If Wi-Fi was querying an AFC type database, I'm not saying the AFC database as it exists today, but a database like that. What kind of threshold levels would we need for detection of mobile signals by Wi-Fi? So we see a little bit of that in NRU today, where particular preambles are transmitted so that Wi-Fi is better. Recognizing that NRU is unlicensed or license exempt, we would refer to it in the UK. That doesn't necessarily mean that an NRU type protocol couldn't be applied in a kind of licensed way. So, what would need to happen to 5G mobile so that Wi-Fi could detect it better than it can today in its current ability? We're trying to look at parameters that would be needed to protect Wi-Fi. So if we were deploying stuff through through some automated spectrum access database or SAS database, the kind of CBRS type band that you've got in the US at the moment, that would be a database queried by the mobile operators. It might well be that we actually want one database where you've got a kind of you've got an SAS type interface for the mobile industry to talk to, and you've got a kind of AFC type database for the Wi-Fi industry to talk to. That might be one way of of kind of combining those things. I talked a bit about the preamble stuff already, and that kind of single solution for databases. But we're also thinking about the fact that Wi-Fi at the moment just gets degraded and doesn't switch to a clean channel. And so in some cases, Wi-Fi switching away is not great because you don't really quite know how much spectrum you've got available in an area. But if you were to choose mobile for upper 6, Wi-Fi gets no access. If Wi-Fi can make opportunistic access where it's available, then that frees up the load on lower 6, for example, and that would be a good thing. Equally, if we chose the band for Wi-Fi and mobile was entirely excluded, then maybe mobile doesn't get exactly what it wants out of this, but mobile gets access to some spectrum in some locations or at some times of the day, week, month, whatever that might be. But all of this requires collaboration. We really do believe that benefits of both technologies can be realized, both are going to be possible, but we think actually cross-industry collaboration is going to be needed, and that it's not trivial, right? We recognize that the different industries talking to each other and engaging and finding a common solution that works for both is possible, but is difficult. So we're kind of exploring at the moment the kind of collaboration that we can have with industry, that we can have with academia, that we can have with other regulators. In fact, in CEPT in Europe, we're leading a work item. We put forward a work item around hybrid sharing and how that might work and what the parameters might be, to start having that engagement and that discussion at a kind of harmonization level. We've got a sharing event, just a bit of a plug for that, on the 18th of October. That's 2 o'clock till 5 o'clock UK time. So that might be quite early for some of you, particularly if you're on the West Coast, but we'll send around the slides afterwards, which will have the link for, if you're interested in joining that online event as part of that. I would be, to be clear, we're not looking for people to lobby for mobile or lobby for Wi-Fi in the band. We've heard a lot of those arguments, and frankly, we're a bit unconvinced about the demand on both sides. Actually, we want to kind of go, if we want to make hybrid work, what would we need to do? So we're trying to have that, and then we're looking at kind of workshops and trials in 2024. And again, if people are interested, industry, academia, other regulators in kind of participating in some of those things, then please do get in touch. There's an email address there. We're trying to piece together what some of those things look like. And so that brings me to the kind of end of this, and I'm kind of happy to take some questions.
Thank you very much, Steve. There's a very robust discussion happening in the chat, as you were talking, which I'm sure you've not been following, but clearly
I haven't.
there has been a lot of interest in what you've been saying. This is a pretty new way of thinking about how you can share spectrum. So I'm going to ask people to ask their questions directly. So the first one that we have in the queue is Graham McDonald from Apple. Graham, please unmute yourself and ask your question.
Yeah, thank you. Can I just check you can hear me okay?
Yes.
Okay, perfect. Yeah, there's been a lot of discussions back and forward. Just one point from an Apple perspective. We are in both the IMT community and the license exempt community. So we're maybe in a unique position to see both sides of the arguments. And we've been actively lobbying for the 4+ years that I've been with Apple for IMT identification where it's needed. But we've been crystal clear that from our perspective, the full 6 GHz band needs to be certified for license exempt use in products that are certified and shipping today, not just from Apple, but from hundreds of other manufacturers, etc. If you look at the Wi-Fi Alliance database for certified products, these are for the full 6 GHz band, not just the lower 6. And the problem that we're having, or will have, and this is maybe coming to the question in a second, is that we seem to be getting to a point where the IMT community have made a very substantial case, if you believe them, for the upper 6 GHz. But it's difficult, I guess, for regulators to take into consideration the fact that there's products shipping today, and how would that impact any requirement for sensing or databases, etc., if you require a change to an IEEE standard for stuff that's shipping right now in Apple products, for example. And the other element to consider, and again, the questions are kind of listed there, maybe we can take them offline, but the other point I made was you need to look at the traffic. I know that we looked at the traffic growth, but you need to look at the actual traffic over the network. And if you look at what will be over a 6 GHz license exempt network, it's significantly more than any IMT base station will require. And to my understanding, the arguments being made for the capacity requirements for the upper 6 GHz for IMT is in very limited geographical locations, including maybe down to base station by base station level. So does that really justify this level of hybrid sharing that we're getting involved in? But for the record, we are participating in the sharing discussions and have constructively contributed to that debate. But it'd be interesting to see if people have really taken on board the actual traffic requirements, or are we just trying to sort of provide a level playing field, but is obviously completely biased if it doesn't really take into account the less exempt requirements. Thanks.
Thanks, Graham, and yes, we've had conversations about about where the demand is and where the traffic is, and I might not get drawn too much on that. I think there are proponents of it for mobile that would probably say something very similar, but on the other side, in terms of the shipping point. And kind of products that are shipping today, it's one of the reasons that we actually want to get going, and we kind of want to move on that, on this. We sort of recognize that, as I said at the beginning, and different people will have different views of this, but our view is actually deciding mobile or deciding Wi-Fi is not the simplest thing for us as a regulator. Both parties make cases. And some might say both make compelling cases, or some might say both don't make compelling cases, depending on which way you look at it. But either way, there are both sides of that, and we think actually sitting back for the next 3 years and not doing anything isn't the right answer here. And actually, if we can leverage the benefits by hybrid, that's kind of what we want to achieve. But we also recognise that we want to get on and do that quickly for exactly the points you make, Graham, about the products that are shipping, about not getting too much stuff out there that doesn't have the things in it that it might need going forward, and those kind of things, for example. I'd probably not go as far as saying speed is of the essence, but we do recognise that kind of getting on with this, and you'll know, Graham, that we pushed quite hard for that work item in CPT to kind of get on with stuff. While some administrations were like, no, wait till after WRC, but we pushed quite hard to kind of get it going and get it started, and we've pushed. We've pushed to kind of get our consultation out the door, and that's now closed. We will be, we're intending to publish all of those responses before WRC. We're intending to, to kind of do a bit of a summary of those to make that easy for people as well, so people can kind of see all of that. And so really, we see our role partly in this is about facilitating the discussion and just making sure that we're providing information so that people can kind of have all of this. But yeah, I note your point about about stuff that's shipping, and we do want to, we don't want to sit on this forever. We do want to kind of get it going, and that might be where we end up with some compromise somewhere, because we could either have the the best sharing mechanism on the planet that's most efficient, but it takes 5 years. That might not be the right answer. Something that's a bit of a compromise that maybe takes a bit less, takes less time to implement, but isn't quite as good, might be the better thing. And I think it's fair to say that we are open to all of those discussions and all of those considerations.
Thank you for that, Steve. I think just zooming out a little bit, just by bringing this topic up of hybrid sharing, where we are now looking at not just incumbent and cellular or incumbent and Wi-Fi. We are trying to think of ways that we can get incumbent cellular and Wi-Fi to work. Maybe it doesn't go anywhere in 6 gigahertz, but I think as a research community, which is a lot of the Spectrum X members, even thinking about these issues for the longer term, other frequency bands, to me, makes sense. I think the next person who had a question in the chat was Monica Paolini. She had some comments, and then we'll go to the raised hands.
Thanks, Manisha, and Steve, thanks. I'm a big fan of Ofcom, so I read all of this with a lot of interest, but I am of two different minds on your proposal. Clearly, your heart is in the right place, but are we introducing too much complexity in the sense of, and that might just slow down the market? Because clearly there is a demand for 6 gigahertz. Now, how is that going to work out? Fine. But if you do not have a hybrid model, you're basically allowing both 5G and Wi-Fi to use. So mobile operators are not excluded just by using an unlicensed model. They have to coexist. So I think that, we should, and as you mentioned, clearly coexistence is a top priority. So shouldn't we just work on that? So make it unlicensed and then focus on coexistence the same way, because that would not put the UK in a corner where you need to have special equipment for the UK, which is necessarily going to slow down things. So it's the simplicity issue. So it's like the Occam razor thing. I mean, why do we need to have something more complicated at the beginning when everybody can use it?
So I think, I mean, to some degree, we recognize that challenge, and we don't particularly want to slow down the market. But actually, if you listen to if we listen to the mobile community and what they're asking for high power mobile outdoors or macro size. That does not operate in a license exempt way. That causes massive amounts of interference, kind of, to all sorts of incumbents, to themselves, to other things, kind of outdoors, if that's not managed. And we would manage that in the UK via the licensing framework. So if that's the kind of service that we want to try and enable, then some kind of management is necessary, and we can't just make it a license exempt kind of free for all. And in a way that maybe in 5 gigahertz NRU, kind of lower power NRU and Wi-Fi, we can debate about how successful that is, maybe, but actually they're kind of making use of that in that kind of licensing way that I think maybe you envisage. But that's why, we've kind of looked at, how does the listen before talk function work? How does energy detect functions work? How are the existing kind of, database technologies working, and how can they actually be leveraged? Because that's the way, if I start from scratch with a blank sheet of paper, it's going to take ages, right? And it's going to be costly, and it's going to slow down development cycles. If we can look at something and tweak a few parameters in it or enhance it a little bit, I'm kind of hopeful that should be faster to deliver. And so that's why we've kind of started from there, rather than saying, let's start with a blank sheet of paper. We're starting with something that we know is in product today, is developed in product today, and therefore development cycles, will be a little bit shorter, we hope.
But isn't the issue that, I mean, in the areas where you use mobile operators, we use 6 gigahertz, it's like the high dense areas. So you don't want to have a big macro, because that wouldn't work for them either, right? So they need to it would be better for them to have somewhat lower power and have like small cells or micro cells, and maybe they don't need all that power that they would need if they were using macro. So maybe it's all for them to kind of adjust to the mindset of 6 gigahertz.
And and we are open to that as well. We recognise the answer might be you need a more medium power from a kind of mobile perspective, both to manage the incumbents, but also to manage the the kind of hybrid sharing that we're after. So there are definitely options. And as I said at the beginning, we don't have all the answers at this point in time. What we are trying to do is stimulate the conversation, and that's why events like this are just so helpful for us, because it does kind of stimulate that conversation.
Yeah, I think potentially you're looking at a future where if you have hybrid sharing, you have Wi-Fi and NRU and regular 5G and incumbents. So you can think about many different ways. And just a quick comment on operators using unlicensed frequencies. I've done past work on 5G on LAA and 4G. I haven't seen 5G NRU, and absolutely, in hotspot areas, operators make very good use of the additional bandwidth in unlicensed spectrum, and you can get a really good throughput and coverage. So that's another way that operators could use the spectrum. I think Alex is next with his question. Alex, go ahead.
Thank you, Manisha. Thank you, Steve, for the presentation. One question I have: you mentioned that Wi-Fi as is and 5G as is would not be able to successfully share. If I understand well, that implies that then we need changes to the existing standards, either through AR interface changes or through support of databases or something in between. I just want to make sure I understood it right. So some changes are needed, and you would be interested in minimizing those changes so that you enable coexistence. Is that the fair step?
Yeah, no, I think that's fair. I mean, I'm not saying there will be some places and there will be some ways that both can share as they are today. If they're in quite different geographies, for example, if we only enabled mobile in the high density areas, high demand areas, Wi-Fi elsewhere. But then the Wi-Fi community is telling us they want to be in those high density areas too. So when you're looking at the same geography, and there'll be some buildings where you've got lots of building entry loss, and therefore, Wi-Fi indoors and mobile outdoors will absolutely work. But what we recognize is that we can't create a kind of regulatory regime where it sort of works sometimes, but then when it doesn't work really badly. We don't want to be in a position where actually you've completely killed use of one of the services because of the other one. It needs to be able to deal with that. Now that might be that's only minor tweaks to protocols, but as you say, Alex, we are keen to minimise some of those changes, because the point that the previous question was about speed to market, and I think Graham said from Apple as well, it's about product shipping. We don't want to be here in 10 years having a debate about exactly what the protocols need to be to make this work. In 10 years time we want to be patting ourselves on the back and saying what a great success this was.
Mm-hmm. And for mobile side, does that mean that there needs to be some exclusively licensed spectrum so that to justify the deployment, so this could be more like a auxiliary spectrum for mobile?
Yeah, I mean, I think so. Where mobile is going to get kind of excluded from an area as part of it, or excluded from something else as part of it, then absolutely this becomes additional capacity spectrum. And I think I'd be quite surprised if any mobile operator was going to tell me they were going to run a network on upper 6 only, because I think actually it just doesn't give the level of indoor penetration that they're kind of expecting. I think one of the comments in the chat, it might have been from Graham, was kind of suggesting that kind of building entry loss just means that mobile networks need a mix of bands. That's just the way they work in terms of capacity and coverage. So this is just another band as part of their portfolio. If you don't get access to this in a particular area or particular, it might even be a small pixel of, depending on your database size. If they don't get access to mobile, well, they've got a whole bunch of other bands that they can use. So we're not saying customers are not served. Similarly for Wi-Fi, you've got other bands that you can fall back to in both cases.
Thank you.
Thanks, Steve. Kumar?
Yeah, thanks, Steve. My question is regarding whether you've looked at the economic and the business value chain aspects of this, essentially to understand what are the circumstances under which the hybrid sharing can actually work in such a way that it benefits both the end user and the business ecosystem. One of the issues over here, of course, is that the majority of mobile network users are located indoors. So you have to really think about how those users are going to continue to be served, and how operators who invest in networks can get a return on their investment if they have to relinquish the spectrum to Wi-Fi in certain areas.
So I think the really short answer is we've given it a little bit of thought, but not very much. And the slightly longer answer is, and the reason for that is that we sort of started thinking about this and we started looking at this, and actually what we ended up with was, but actually the value of Wi-Fi depends on the sharing mechanism and where it's got access and where it doesn't have access, and the value of mobile depends on where it's given access and where it doesn't have access, and therefore it's really difficult to have that debate now. That debate and that kind of cost and kind of business case and kind of more economic analysis, that stuff needs to be a bit later in the process once you kind of know. And the test for us is we're pro innovation. We're not averse to the fact that innovation comes at a little bit of a cost. So we might be pro innovation, which we think's got kind of wider social benefits or wider benefits to the community. But clearly we don't want to be in a position where we've basically made the value of Wi-Fi 1% of what it would be if it uniquely had the band, and we made the value of mobile 1% of what it would be if it uniquely had the band, and we've got a sum total of 2%. As opposed to if we picked a winner of mobile or Wi-Fi in the band, it would be 100%. That clearly would be a really bad outcome, actually, from that perspective. So we are cognizant that we need to be in a position where I would say we've enabled most of the benefits of Wi-Fi, and we've enabled most of the benefits of mobile, and then actually the sum of those two should be greater than just choosing one. I mean, that's the perfect economic theory, right? So that's what we would kind of like to get to. But we do recognise that a bit more thought will need to be given to that once some of the sharing mechanisms are kind of better understood and better thought through as to how that might work. At the moment, we've just got scenarios, really.
So in the interests of time, and thank you very much for engaging the audience with the questions and the answers. I love that your statement that you're all for innovation. At Spectrum X, we're all for innovation too. And I think one of the key takeaways that I get from what you just presented is, yes, there are a lot of unknowns in terms of business and economics, but there are a lot of really interesting technological threads that need to be studied. And we've started doing some of that work already in Spectrum X in 6 gigahertz. And we are really looking to collaborating with other regulators like Ofcom, with industry, many of whom are on this call, to push these ideas forward, because so much of this has to be tested and measured and deployed and understood on the ground, so to speak. We have a couple more minutes left, and I see Graham has his hand up. Graham, a quick question or comment from you, and then we'll close it out.
Yeah, just a very quick question in response to Steve and the comment regarding access to other bands. Wi-Fi does 2.4 and 5, but not for the new applications and services that Wi-Fi 6E and Wi-Fi 7 are looking at. If you look at Wi-Fi 7 with capabilities for 320 megahertz channels, that doesn't fit in other frequency ranges. So the point that Apple's trying to make everywhere is that when we talk about license exempt access to this particular band, it's because there's nowhere else to go. That's why 6 gigs is so critical for us. And just another point with respect to outdoor to indoor penetration, you need to look at the carbon footprint for all of this as well. There is no way on earth that a high power INT network delivering indoor uses to end users, services to end users, has a lower carbon footprint than using Wi-Fi indoors. So there's that element as well, the carbon footprint and the fact that Wi-Fi has nowhere else to go. Thanks.
Thanks, Ram. And yeah, I think we're going to have these discussions for a long time now, not only in 6 gigahertz, but as the newer, FR3 bands get looked at for future generations. And we hope that we keep the conversation going. Again, from the audience perspective, please feel free to engage with Spectrum X and keep coming to our talks. Nick, any last words from you?
Well, just once again, thank you all for participating. Thank you to Steve for the presentation and the discussion. And let's keep those discussions going.
Yeah, no, thanks a lot. And I think, Monish, you summarized it really well, right? There's lots of technical threads, probably some economic ones as well that need to be kind of teased through and kind of worked through. And what we're really trying to do is just start that conversation, start that drive. And as you say, upper 6, but I sort of see this hybrid, we sort of see this hybrid sharing is something that, could apply in other bands in the future, right? I mean, who knows what the future looks like, but we sort of think as you try and pack more users together, you need more sharing. And upper 6 is one that's a kind of prime candidate for looking at this. And we kind of alluded to that in our document, but, I'd be quite surprised if it stopped there, I guess.
Great. Thank you all.
All right.
Thanks a lot.